All right, all right, all right. Okay, welcome to ICT. I think it's 2632. So it's basically digital systems or digital logic. So I thought, because I don't know what's wrong with my UNISA, but some people told me that they can't comment on they can't reply to the discussions. So I thought maybe let's just get over and done with. Normally, I like having sessions after assignment 1 because people understand how to convert. Most people normally understand how to convert from binary to decimal. But I thought this year, let's just do it a bit different. Let's start from the scratch, especially for those ones who have never seen anything like this before, who have never worked with binary and decimal. All right, so so the session is normally just 1 hour. So we'll have another one maybe on Tuesday. So the aim for this is to just make sure that you guys get a distinction. So this is one of the easiest module there is, especially if you understand what's going on, right? So decimal, so we basically have number systems. I know some of you, this is gonna bore you because you already know this, but we have different number systems. We have decimal. Decimal is just basically 2 possibilities. That's why it's denoted by a 2. So this 2 is basically a subscript. So this will be something like 1, 1, 1, 1, 0, 1, right? And then the comma, then 1, 1. So this 2 will be down here. So this 2 represents a number system. This is a number system. So this number system is binary. So it only has 2 possibilities. That's why it's a 2. So the 2 possibilities are a 1 and a 0, right? So now, how about a 69? Let's talk about the 69, a normal 69 that we know. A normal 69 that we know, the number system that the world uses, it's basically this, to the base 10. We call it the base 10, right? So why is it the base 10? It's because there's 10 possibilities. For you to write any number that you know, like your money and stuff, you only use numbers from 0 to 9, right? Inclusive, all inclusive, right? Sorry. All inclusive. So this means 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. All of them, they make 10 possibilities. Remember, you include a 0 and you include a 9. Then in between, you have 8 numbers, which is your 1, 2, 3, 4, 5, 6, 7. Yeah, so basically you have, in total, is 10. So that's why you have this base 10, right? Then we have the hex. What is that? Hex number system. Let me just say F5. F5. Let's say 6. A hex will be denoted by a 16. So it just means that there is 16 possibilities, right? And then a hex from 10. I'm just covering this so that you know the basics when we start doing the real stuff. So from 10, a 10 in hex translates to NA, right? A 10, 11 is gonna be a B. So 10, 11, 12 C, 13 D, 14 E, 15, yeah, 15 E, 15. What is 15? 15, is it a F? 15, I think it's F. 10, 11, 12, 13, 14, 15. A, B. Then here we're going to have a C, E, and then an E, and then an F. right? So this will be 12, 13, 14, 15. Yeah, 15 is an F. So remember, it's inclusive. It starts from 0. So it doesn't start from 1. So that's why you have 16 possibilities, because it starts from 0. So this will be your 12, your 13, your 14, and your 15, right? So we also have the other number system that we have. So remember, this one is binary. Then this is decimal. This is hex. We have octal. Octal is denoted by an 8, right? So they can say 7, 7, 5, 7, 5, 8, right? So it means its numbers will range from 0 to 7. So they will just range from 0 to 7. That's the octal. Then we have the binary coded decimal. Okay, can I not cover that one? So binary coded decimal is a binary calculated in a decimal form. I'll show you. I don't want to confuse you with that one. So let's focus on this one. I'll show you from my notes here. How do you convert it? So if you're gonna convert this and convert that one, you're gonna be a bit confused. So the 4 or 5, how many? 1, 2, 3. Yeah, the 4 major ones are these ones. The 4 major ones are these ones. So today we're going to be looking at conversions. Conversions are normally the basics of digital systems, right? So you will be asked to convert this into decimal, for example. So you need to be able to convert this into decimal. Then even if they say convert it to hex, stuff like that, you need to be able to do that. Okay. So let's start with the simple one. Just the basics. 1, 1, 1. Let's convert this to decimal, right? So when you convert something to decimal, a 1 means present. So in digital systems, you have 1 and 0. So remember, for a computer or for electronics to be able to know if something is on, it needs to be a 1. Then if something is off, it will be a 0, right? So now this bit, what is this? The least significant bit, I think. So this will be 2 to the power 0, right? This one will be 2 to the power 1. And then this one will be 2 to the power 2, right? Remember, everything to the power 0 is a 1, right? Then you can just add it with this one. 2 to the power 1 is a 2. And then 2 to the power 2 to the power 2 to the power 2 is a 4. So this is basically a 7. Right. So now 111, it's a 7 in binary, in decimal. So 111 in binary, it's a 7 in decimal, right? Okay, so let's do another simple one. Okay, these are my gates. Let me look for something. Okay, let's come here. Let's do it the other way around. 52. Now this is decimal. The question is convert this into binary. So now what do we do? Okay, great stuff. So we know we have basically 2 to the power 0, for example, 2 to the power 1, 2 to the power 2, 2 to the power 2, Yeah, pretend this is a 2. 2 to the power 3. Okay. So this is 1, 2, 4, 8. I want you guys to see the pattern here. 16, 32, 64, but 64 is bigger than 52, so we're never gonna use it. So I'm not gonna put it there. So this will be 2 to the power 4, and then this will be 2 to the power 5. 2 to the power 5, right? So remember I said 1 means present and 0 means not present. So this will be present, not present. So not present means it doesn't exist, right? Not present. All right. So in 52, a 32 must exist, right? A 32 must, 64 cannot exist. So here I wanted you guys to see this pattern that going to the left, all these numbers, they just double. So you don't even really need to remember this. You can solve this without a calculator. So this is 2, 4, 2, 4, 8, 16, 32 is just doubles. And then the first one is 2 to the power 0, 2 to the power 1, 2, 3, 4, 5, 6. And so you will get sometimes up until 2 to the power 6. Your problems will be up until 2 to the power 6. But mostly they are here, but they will be 2 to the power 6. Okay. So now if you get that, all right, we don't want to use 64, we're going to use 32. So we're going to say 32, this bit is present. We're going to make this bit present, right? So now on the side, we're going to say 52 minus 32, which is 20, right? 20. 20. 20, right? So now 20 is bigger than 16. So 20 is bigger than 16. Remember 52 was bigger than 32, so that's why we used it. So now we need to use 16 because it's smaller than 20, so 20 is bigger. So we're going to make it be present here, right? Then after present, we say 20 minus 16. We will be left with a 4, right? So now remember we left with the 4. So we can't say 4. Okay, 4 is not bigger than 8. 8 is bigger than 4. So we're not going to use this bit here. So we're going to turn it into a 0, right? Remember, we need to say we had a 20 here. We said 20 minus 16. So now in this case, we're supposed to say 4 minus 8, but we know 4 is smaller than 8, so we don't need this one. If we add this 32 plus this, it's 48 already, 48. So we can't add another 8, it's going to be 56. That's why we turned it into a 0. Okay, so now 4 into this 4, it passes, right? So this is going to be a 1 here. So this is going to be a 1 here. Then we're going to say 4, this 4 of ours here, this 4 of ours here, minus 4. All of this, what I'm doing on the side, you can just do it in your head. It's just that I'm trying to show you how to work it out, right? Then we don't need this. Remember, 0 means not present, and we don't need this again. Are you guys with me? So the last one mark comes here. You need to show this was binary, right? So the answer for this is 110100. Okay, let's say they say we must convert this back, right? We already know this is 2 to the power 0, 2 to the power 1. I'm not going to go through everything. We know this is 1, 1, 2, 4, 8, 16, 32, right? We know it's that. So this one, for this bit, okay, let me just put 1, 2, 4, right? So for this bit, the bit here, this one is not present. So some people can say 1 multiplied by 0, but it simply just means that it's not present, right? So we throw away this one. So it's not present. We throw it away, right? Then we come here. 2 and 0 is not present. So we do what? We throw it away. But let's do it like this so that maybe you can also understand. 0 plus. So this is 1 multiplied by 0 is 0. 2 multiplied by 0 is 0. This is us converting back. So 4 is present. Remember, 4 is present. 4 multiplied by 1 is going to become a 4 here. Then 8 multiplied by 0 is going to become a 0. It's not present. So you can just say it's not present. 16 multiplied by 1 is going to be a 16. 32 multiplied by 1 is going to be 32. So 32 plus 16 plus 4. Remember, 16 plus 4 is already 20. So plus 32 is going to be 52. So the answer here will be 52. Yeah, 52, 10. So you don't need to write this 10. So we can, because this number system is already to the base 10. It's decimal. All right, but let's go to the real problems that they will ask. They'll never ask you something so simple. So let's see, what will they ask you? Okay, they will ask you something like this. I think we will just break it down. Okay, guys, I've never seen your assignment, so that's why I don't like checking the assignments so that we don't end up doing the problems that are in your assignment. So that's why I don't look at your assignment. Okay, anyway, let's make it simple. This is 1, 2, 4, 1, 2, 4, 8, 16, 32. So, okay, it has up until 32. So we'll be able to do this one. All right. So this comma, everything behind on the right side of the comma, on my right side of the comma, becomes to the power minus, right? And everything on the left was positive, right? So we did everything on the left, but everything on the right, it goes to the minus. So let's do this. So I'm gonna remove this 2. So remember that 2 just means that it's in binary form. Great stuff. Okay, let's start. So let's start here with what we know. So the first one we know is 2 to the power 0. 2 to the power 0. 2 to the power 1. 2 to the power 2. 2 to the power 3. 2 to the power 4. 3. 2. And then 2 to the power 5, right? We know this is 1, 2 to the power 1. This is 2. This is 4. Everything just doubles here. 4, 8, 16, 32. Right. So we know we're going to add everything that's present. So this one, we're not going to add it because it's not present, right? So we're going to add 1, 4, 8, 16, 32. Simple as that. So this is 1 plus 0 multiplied by 2, which is 0, plus 4 plus 8. Remember the 4, it's 1 multiplied by 4, it's a 4. 1 multiplied by 8, it's an 8. 1 multiplied by 16, it's a 16. 1 multiplied by 32, it's a 32. So this is 16 plus 32. 32. 32. Okay. So 32 plus 16 is 48. Plus 8 is 56. Plus 4 is 60. It's 61. So here it's 61, comma something, right? Okay. Now we on the right hand side. So this first one will be 2 to the power. Remember this was 0 here. This one was 0. So this one will be 2 to the power minus 1. Then 2 to the power minus 2. 2 to the power minus 2. So going all the way to the right, this was going to be 2 to the power minus 3, minus 4, minus 5, minus 6. Yeah. So 2 to the power minus 1 is a half. So we basically just dividing by 2 all the way. So here we were doubling everything. So here we're getting half of everything, right? So this will be 0 0.5, 0 0.5. 0 0.5 divided by 2, I know 0 0.25. So if maybe there was another one here, so this was going to be 0 0.0125, right? 0 0.125. 0.125. Then the last one here is the one that I forgot. Is 0.066 something. Do you get my point? Yeah, 0.06 something. So let me see if I use a calculator. So they can ask you up to four decimal places after the comma. So now you need to have that number. If you don't wanna, you see, I always forget it. But if you have a calculator, you just divide by 2. So let me just confirm for you guys. 0 0.25 divided by 2, 0 0.125, which is correct, divided by 2, 0 0.0625. So I was correct. Okay. 0 0.0. So I will share these recordings. I think I'll put them on YouTube, then you guys can just get them from there. So because I'm going to delete this after this, 0 0.025, right? So if there was a 1 here and a 1 here, so then you know that it was going to be 2 to the power minus 3, 2 to the power minus 4. It was going to give you 0 0.0125 and then 0 0.0625. Okay. So let's focus on the problem now. Okay, so here's the problem. So here it was 61. So now we know this bit is present, right? So this is 1 multiplied by 0 0.5, right? So we can say 1 multiplied by 0 0.5 is 0 0.5. So we're going to have 0 0.5 plus 1 multiplied by 0 0.25 is going to be 0 0.25. So 0 0.5 and plus 0 0.25, it should be 0 0.75, right? So the answer is 0.75. We don't need the 0 because the 0 is added this side, right? So it's 0.75. So this is our final answer. So this is the format. You will get this. You will get this in your assignment. You'll get this in your exam. So this will be straight. You'll get it straight in your exam. So you can take a picture of that one. You can, yeah, do whatever you want to do with it. But yeah, it will be in the exam. Okay, I'm not the lecturer, but I know she will put it. Actually, it's a he this year, I think. He will put it. Okay, so here it is. We got it right. So you don't need the 10 because it's base 10 already, right? But if it was in hex or something, you were going to need it here. Okay, so there is one here, 70 hex. Let's see. So this one you just divide by 16, 16. So this way they need a calculator. That's why I hate this method of theirs. But anyway, let's do it. I'm going to show you this method and then I'm going to show you my method. But just know that I hate this method of theirs because you need a calculator here. Okay. So, but now your markers are very intelligent nowadays. They can mark two methods. So it's not like in the past where they used to think only one method, which is on the memo, is the one that works. So you are safe. Whichever method you use, you are safe. All right. So now, when you convert this decimal number to hex, remember I said hex is to the power 16. Okay? So you take this big number, you divide it by 16. Simple as that. Divide it by 16 each and every time. You just divide by 16 and divide and divide and divide. Okay, so let's see. 7, 0, 6, 5, divided by 16. This is equals to, now I need a calculator. 7065 divided by 16 is equals to 4, 4, 4, 4, 4, 1. So here we use the remainders. The remainders is what we use. Remainder. Okay. How do I know my remainder? 441. Okay, let me do this. 441 multiplied by 16 is going to give me 7056 minus 7065. The remainder is 9. Remainder is equals to 9. Right? Okay, 441 remainder 9. Okay, let me just confirm what they have there. Yeah, okay, then it's 441, then it's 27. Remember I said I don't like this method. Anyway, then it's 441 here. This, you take this, you literally just take this. 441 divided by 16. So you're gonna write the answer, then you just gonna take the remainder. So let's see. 441 divided by 16 is 27. 27. Remainder. Okay, let's see. 27 multiplied by 16 is 432 minus 441. The remainder is 9 again. Okay, 9. Great. So this is still big, right? So 27 is still bigger than 16. So we can go on again. 27 divided by 16 is gonna be 1. Divided by 16 is equals to 1. Yeah, 32. So it's 1. The remainder will be 27 minus 16. Should be 10, 11. It should be 11. Remainder. It's 11. Now we're going back to what I started with. Remember I said 11 in hex, it's a B. Let's see if we still have those notes. 11, here's 11. 11, it's a B. So this will be a B. It will be a B. Right? Let's just confirm here with them. Yeah, they got the B sharp. Okay, they got a B as well. So here it's a B. Right. So now what's your answer? Your answer is, here's your answer. Your answer is 1. You take this one, right? The last one, the last number that was divisible, you take this. If this was a 2, you are going to take a 2. And the last number that was divisible, basically. So it's a 1. B, you take all the remainders the way they are. 1, B, 9, 9. So what is this again? Yeah, 1B99 to the power, sorry, by 16, right? So this is this answer in hex. So this was in decimal. To convert it to hex, what we did was we divided by 16. We took the, is it a product as well? I know product is multiplication, but yeah, we took this product. Let's just call it a product for this sake. Then we multiplied, we divided by 16 again. We took it, divided by 16. So here we couldn't divide anymore. So this was the last divisible number. So our product was 1. We took the 1, then we took all the remainders and put it as part of our answer, right? To the power 60. Okay, so you have this always in your exam. This always in your exam, right? So we're basically focusing on question 1 of your exam papers. Okay. We don't need this one. Let's see again. Yeah, here comes octal. So remember I said octal is to the power 8. So I think we're gonna do method. You say I don't like this method of test, it's too difficult. We're gonna do octal in my method for this case. Then BCD, I'm not gonna confuse you with that one. I have the notes. Oh yeah, then I want us to do 1's complement and 2's complement, and I think we'll be there. So let's try to do octal. Let me just copy this. Let's do octal quickly. Oh no, they want it in hexadecimal. Okay. Okay, so you saw this method to convert to hex. Then I'm gonna show you a different one. I think we can do both methods here. The simple one, if you forgot your calculator, if the calculator is not next to you, this is what you can do, right? Great stuff. So if they were to say to you 52, remember we had the answer of 52. We had 52, that 52. in hex, right? In hex. What you would do is you would, this was 52. You would convert it to binary. You can convert it to binary like this. So to binary, it's 110100, right? 110100. You convert it to binary the very same way that we did there. It's 110100, right? Then from there, what you do is hex. In hex, you group in 4s. When you talk about hex, you group hex, you group your binary, all these bits, you group them in 4s. Group in, in hex, in 4s, right? Then in octal, you group in 3s. Group in 3s, right? So now this into hex, it was gonna be this 4 together, this 4 together, right? So this is 1, 2. We know if something is not present, what do? We put the 0, 0. Yes. Now we're gonna have another 4 here. So remember, this is 1, 1, 2, 2, 4, 8, right? 8 plus 4, 12, 2, 14, 15. It will never get to more than 16 because it starts on 0. It's 16 possibilities. 1, 2, 4. So the answer here was going to be 4, right? And then here, again, 1, 2, 2, 4, 1, 2, 4, 8, right? 1 and 2, 1 and 2 is going to be 3. So the answer here is 3. 1 and 2, 3. So this was going to be your answer in hex, right? In hexadecimal. So now let's get that answer in octal. Let's get this answer in octal. So in octal, we're going to have, you can take it to this first, right? So we're going to have in groups of 3. So it was going to be, we need to start this side, 0, 0, 1, 0, 1, 1. Now we group in 3s. We're going to group this one together. Then we're going to group this one together. So here we're going to have 1, 2, 4, 1, 2, 4. So the answer was going to be, this is not present, this is not present. 1 by 4 is a 4. And then here, 1, 2, 1, 2, 4. Right? So this was going to be a 6 to the power 3. Sorry, to the power, not to the power. What is this thing? Subscript, maybe subscript 8, right? So it's 64 subscript 8. This is this in octal. Are you guys still with me?
Yes.
All right.
Yes.
All right. Okay, I just want to jump straight to one's complement so that you can have a variety of these things. Okay, one's complement. Let's do one's complement. So guys, again, you need to be able to add binary, right? So start with distance. These simple things are, so you need to just know these rules. then they will help you a lot. 1 plus 0, it's a 1, right? 1 plus 1, it's a 0, carry 1, right? So it's going to be a 1 here. Now, this is the important one. You always get this somehow. 1, 1, let's say 1. Yeah, okay, let me do it. It's fine, let me put a 0 here. So we're gonna need to do 2 examples there. 1 and 1, it's a 0. Remember, 1 and 1, it's a 0, carry 1, right? 1 and 1, it's a 0, carry 1. Remember this, here's the law. It's a 0, carry 1. So this one was gonna come here. But what do you do in this case? 1, 1. So I saw most students struggle here. 1, 1, right? 1 and 1. Remember, here's the law. It's a 0, carry 1. Now, here's the challenging one. 1 and 1, it's a 0, carry 1. And a 1, what is it now? Do you understand? Okay. So remember 1 and 1, it's a 0. It's a 0, it's already carrying 1, right? 0 and 1. 0 and 1, it's a 1. So here your answer was just going to be a 1, and then this one a 1. So you know this 2 already carries a 1, and then you just put this 1 down. And that's it, right? So this 3, these are just the basic fundamentals of this. I'm teaching it like they taught us in grade 8, eh? So we did this thing in grade 8. So this is the where it comes from. It comes from that. So one's complement, they will say to you 1 0 1 1 0 0 1 1 0. They can say to you, convert this into one's complement, right? So one's complement, it's just the inverse, right? It's just the inverse. The inverse is the opposite. It's the opposite, guys. Complement, basically the opposite. So 0, here you would put a 1. Here you would put a 0. Here you would put a 0. Here you would put a 1. Here you would put a 0. Here you would put a 0. Here you would put a 1. Here you would put a 0, right? That's one's complement. Now, they might say to you, convert this into 2's complement. 2's complement. Okay. 2's. So there's no need to panic. 2's complement. With 2's complement, you just add a 1. With this bit. What is this bit? Most significant or less significant bit? I always confuse them. Yeah, but anyway, here you're gonna add a 1 here. So before, when you convert something to 2's complement, you need to first convert it to 1's complement. Then you get your marks here, right? Then you add a 1 here. When you add a 1, we know that you are converting it to 2's complement. So this is gonna be 1 plus 1, which is going to be 0, carry 1, right? Then this is gonna be a 1. Then this will be the same, 0, 1, 0, 0, 1, right? this 0 is not necessary, but let's just put it, just that I took a bad example, but let's just put it there. Do you get my point? So all that you need to do is to add a 1. Okay, guys, I'm gonna ask for 2 minutes. Please look for questions. Then I'm gonna answer the questions. You can post them on the chat if you want, but think about them as well. We have more or less 15 minutes left. Just give me 2 minutes. Okay, guys, I'm back. Any questions? See if there's anything in the chat. Okay. So normally I don't even use a book myself. I don't have a book. I don't use a book. But what I do is there are notes that I upload. Let's just go through those notes and see. Unison notes, just that I don't want to be too ahead. So if we go to phase 1, please download those notes and use them. We have had people, the highest was 97%. Was a lady. So I explain what is one's complement. So you see, you can just use this. You will know what's one's complement and what's two's complement, right? So phase 1 is already uploaded. This is the BCDC. I said I don't wanna touch it today. BCDC, here is. If you are already understanding these basics, you can just do this as well. BCDC in phase 1. Binary to decimal conversion, it's here. Binary to decimal, I explain it the proper way. Here's that 0.0625 that we looked at. Boolean algebra, you don't need to do Boolean algebra. Then conversions, task 1, I asked you if you can do this. And then always email it to me if you have time. But you don't need to email it if you don't have time, because a week later I will always send you guys the memo. So this is the memo, the memorandum. So I explain it. So you see, you just need all the answers are here, guys. And then that boring method that I don't like is here as well. So you will be able to do that. Okay. And then sigma notation, it's in assignment 2. So let's see, but I put them for those people who already know these things so that they can start. So binary to hexadecimal, here it is. I'm explaining everything, so you can use that. So no one really, the problem with Floyd is that I think your author is Floyd. Out of all these books, and he's been changing versions as well. So even if you use the oldest one, you're still fine. There's really nothing that you're going to, that you won't find here, that you'll find in the textbook, right? Unless it comes to the flip-flops and the SR lectures. But now if you go to the past assignments or YouTube, you will be fine. So here I solved this one for you guys. You will be able to see. Then you also have some exercises there. Worksheet 3, you don't need that. I haven't seen your assignment, but let's just see. So all those things, this one, the answer, this is basically obviously 2018. The answer is posted. We solved this one. We looked at this one a bit. Okay, and then this one, decimal, we know how to do that. BCD, binary coded decimal. I just have the notes uploaded. We'll cover it next week. 452 binary. Ones complement. You see, that's why I wanted us to focus on ones and twos complement. We did this, the nodes are added as well. We did that, the nodes are added. So we need to add decimal, it's fine, we'll do this. Then we need to add this octals, then we need to add hex. Okay, so it will just be additions. Ones complement, you know how to do it. Twos complement, you know how to do it. Flip-flop, you see, this is what I was talking about. So the flip-flops, you can Google. You can just go to Google and say a flip-flop has, if maybe you don't want to buy a textbook, right? Because it's expensive, but I don't want to lie to you. The last time I opened the textbook was maybe 4 years ago. How many unique symbols are used in a decimal system? Now, remember I was telling you it's 10, right? Then I said hex is 16. I said oct is 8, right? I said binary is 2, right? So what is the value of 2 to the power minus 4? Is that the example that we did, 2 to the power minus 1, which is 0.5, 2 to the power minus 2, 0.125, then 0.0125, which is 2 to the power minus 3, 2 to the power minus 4, 0.0625, right? Then, okay, the gates, I wanted to brush on this ones, the gates quickly. The output, an AND gate 3, what high when the output of an AND gate with 3 inputs, ABC is high when, okay, this is true. Yeah, I wanted that, the truth table. The format used to present logic output combination is called, okay, the truth table. So that one, I don't know how to phrase it again, but let me just do one last thing, only 5 minutes, guys. One last thing for you. Then if you have questions, please post them. Go to my UNISA, post them. That's the first choice. If you can't post them so that I can cover them in the, what am I using? So that I can cover them in the next session that we have, please just post them.
So do you share the, sorry, Larry, do you share the notes?
Yes, I shared the notes. I already attached. So phase 1 and phase 2, it's already on my UNISA, right?
So, thanks.
Yeah, they are there. So just, guys, if you have questions, you don't need to wait. There is a lady who emailed. I responded. I sent her the link as well. So the thing is, even if I respond after, I will not take more than a week though. Even if I respond after 3 days, I will know that let's squeeze those things into our sessions, right? Because what's gonna happen, I'm telling you the truth now, what's gonna happen is if you don't take advantage now, towards that's the due date of assignment 2, many people are gonna come and then they're going to be asking for favors. So now what's gonna happen is your questions, it's gonna be very hard to address your questions if you don't have them now. So if you have them now, post them already. Don't wait for those people. And then I know sometimes you won't be able to attend the class, so I will make sure that I record and then I post it on YouTube. So you see at least your question will be answered or will be solved. And now, again, the question, please just save me as well. Don't go straight into the assignment and choose a question from there. Choose something similar. Do you understand? Then if it's similar, at least I can also defend myself and say, no. I don't even look at the student assignments. I didn't know they posted this question. We worked through it together. So I think that will save me as well. But anyway, I wanna do this quickly, guys. Guys, please remember this is an input. This is an input. This is an OR gate, right? OR gate. It's an OR gate. OR gate. I'm doing it here. I know I always do it as well in phase 3 and phase 4, but I just want to introduce the ones who don't know what are gates, right? And then this is an AND. Sorry, NAND. Sorry, AND gate, and then this is an inverter, right? So this is an input, this is an output. This is input, output. So in an OR gate, if you put a 1 and a 1, you get the 1 out, right? In an AND gate, if you put a 1 and a 1, you also get the 1 out, right? But now in an OR gate, if you put a 1 and a 0, you get a, you get a 1 out. Here, if you put in an AND gate, if you put a 1 and a 0, you get a 0 out. But okay, in an inverter, if you have a 1, you get a 0 out. If you have a 0, you're gonna get a 1 out. But now, how do I know this? How do I know this? So let's go to their formal explanation there. I just know because I know it's a truth table that we use, but here's the answer. The format used to present the logic output for various combinations of a logic input to a gate is called a truth table, right? So that long, boring explanation there, there's a truth table for that. So the truth table, you can go to Google and look for an OR gate. Those guys who are asking me, what must they study, right? You need to be lazy if you want to be very good. OR gate, truth table. So it's not necessary for you to study shift registers and what you study things that they're gonna ask you because you're never gonna use those shift registers at all. I know they have counters. Counters you do them in digits 2 or digits 3, so you don't need to study those things. You just need to study what the syllabus has been using ever since 2012 or 2014. AB, and then let's say C is the output. So I'm already teaching you how to draw a truth table. I know some of you know already. So here, this, what did I say? The most significant bit, I think. So this is 0, 1, 0, 1, right? How do I know 0, 1, 0, 1? So a 2-input gate will have 2 to the power 2 combinations, right? Remember this 2 comes from, there's only one possibility. I said binary. Sorry, there are only 2 possibilities. Binary, it's either it's a 0 or a 1. So combinations, 2 to the power 4 is gonna make 2 to the power 2 is gonna make 4 combinations, right? So this will be 0, 1, 0, 1. So this one will be 0, 0, 1, 1, right? So 0, 1, 0, 1, 0, 0, 1, 1. If there was another one here, it was going to be 0, 0, 0, 0, 1, 1, 1, 1, 4 times. Then it was going to be 8 times. 0, 8 times, 1, 8 times. If it was a 4 input gate or circuit, right? So now let's focus on this case, the truth tables of the gate. So now we're saying in an OR gate, this is on Google, you might just say truth table of an OR gate, but even here, you can have it from here. 1 and 0, 0 and 0 will give you a 0 with an OR gate, right? 0 and 1 will give you a 1. 1 and 0, it will give you a 1. 1 and 1, it will give you a 1. So guys, with the OR gate, it's always like this. This is the truth table. You will never change it. It was like this before we were all born. It will remain like this. That's what they mean, right? So when you go to the shop, Yanka Electronics, when you go to that one in Centurion, and then you go buy an AND gate, this is what they do. So here they're just trying to say, in your car, in your Mercedes-Benz, if you open one door, right, and the other door is locked, switch a light on. That's all that the truth table does, right? So now for you to have that combination, what do you need? You will need a OR gate. Door open, another door closed. Let's say it's a 2-door, 3-door. One door open, the other one closed here, switch the light on, right? Here you're saying, if the door, now you are driving the Uno, if this door is open and this door is closed, don't switch anything on. Do you get my point? I don't know. That's the only example that I can make for now. Okay, so this is the truth table of the OR gate. Let me just do the AND quickly. The AND will be 0, 0, 0, 1, 1, 0, 1, 1. Then we're gonna have A, B, and C, A, B, and C. So 0, 0 in an AND gate. An AND gate is like multiplications, just to make it simple for people. OR gate is like addition, you add, right? So that's why it's denoted by this thing as well, right? Plus, and then an AND gate is denoted by a dot. You understand? So it can be A and B. They say A and B, but you don't need to write this dot because we know AB is multiplication already. 0 and 0 is gonna be 0. 0 and 1, it will be 0. 1 and 0, it will be 0. So now an AND gate, it's only true. The output is high when both inputs are high, right? When both inputs are high, the AND gate is high, the output is high. So here the output is high for an OR gate. The output is high when one of the inputs are high, then the output will be high. Okay, so the inverter, it's 1, then it inverts it to another one. If it's a 1, it will be a 0. If it's a 0, it will be 1, right? So now there's a NAND gate, and there's a NOR gate. So the opposite of a OR gate, it's a NOR gate. We finishing now. NOR gate. And then the opposite of a AND, it's a NAND gate. NAND gate. So the opposite will be a NAND gate. NAND gate. So how do we denote those things? We put this thing. That's why I focused on this inverter. We just put this bubble here. So let me just draw one of them. This is an AND gate. We just put this bubble here, right? Then we know we have a NAND gate. So how do we know the thing of an AND gate, the truth table? You can just convert it to a AND gate like this. You don't need to learn. You don't need to learn about it. Yeah. Then from there, you make the inverse of everything. You just put the 1. You put the 1. You put the 1, and you put the 0, right? This is the truth table of the NAND gate. And for the NOR, it will be a 1, and then a 0, and then a 0, and then a 0. So this, they never really ask, but I just wanted you guys to know the NAND and the NOR gate already. So yeah, you have your gates here. This video will be available. I'll send the link once I've posted the video. We focused on binary conversions, decimal, focused on octal, on hex. Okay, we haven't been here to logic circuits. So that's why I'm already introducing this gate so that when you get to logic circuits, you don't really struggle, right? So that's why I'm introducing this. Okay, guys, any questions?
Hi, sir. It's Kombisile. I wanted to find out if it's possible that you put like these files under those phases that you have there on your PC. I feel like it's gonna be better.
No, thank you very much. You know, guys are not really organized. Okay, I'm going to create those folders. I only noticed yesterday that you can actually create folders yourself and then put phase 1, phase 2, phase 3,
Yes,
right?
please.
Yeah, no, understandable. I agree.
Thank you.
Um, okay,
And
any
then
other
also,
question?
I don't know if others are facing the same thing. You know, when I log on to my Unisa and you're busy posting for us, like whatever, we can't respond. I don't know if others are facing the same thing. I
Yeah,
can't,
yeah.
I can't
Yes.
post anything, or I'm just like you. I saw your email even today, but I couldn't respond.
Okay, yeah, Leandre mentioned that. I think let me just escalate it to the IT support or these people, the Twitter support. Yeah, I'll escalate it. But Leandre said it, just that I thought let's meet first and then yeah, we'll address it. Okay, no, it's fine. I'll address it immediately.
Thank you.
Right. Okay, guys, so are we happy? I wanna stop the recording because YouTube is gonna chow my data. You're telling me this was not recorded? Oh, stop recording. Okay. Shoo.